examining triangle similarity in terms of similarity transformations. All right, so the first thing we're going to do is there's going to be some tools that we're given on the next page here when we click start. And we're going to try to get this blue triangle to match right up on top of this dotted line triangle. The only thing that's not nice about this tool is it's not going to take the letters and the numbers with it. So we're going to have to remember as we turn it or flip it what we're doing to the triangle and match that up. So if I scroll down here and I show you, so it shows you that they translate it over and then they take the triangle and they start to turn it. So here's before, here's after. They turned it, and then before and after again, they flipped it. So now it looks like it's the same triangle or the same shape, and then they made it larger so that it would match. But if you notice, none of the letters are moving with it, and I don't believe it's showing them moving here. I don't believe it actually shows the moving at all. So it looks like this the whole time where you can't see the letters. You can only see the letters of the original figure, the dotted line one. So we have to keep in mind as we're moving this where these letters are moving to so that we can go through here and we can say, when we moved this, F matched up to R, and E matched up to T, and D matched up to S. This actually might be a little easier to do if the letters do transfer like this, to do before we snap it into place so that we remember where the letters are. Because once we know where the letters are, it's really easy to match the rest of this up. Because if I have, this first one tells me ST to DE. So if I look here and I go ST, so I have ST 15, DE is 10, all I'm doing is filling this in and simplifying. So this one's not too bad. It's the angles, they can get a little bit funky if we don't have it correct. So the last part here is just select the true statement. So we want to select, are they similar or are they not similar? If all the angles match up, so all the angles of one triangle congruent to all the angles of the other triangle, and the ratios that we create are all the same, then the two triangles are similar. And if we can put one triangle on top of the other, then they're similar. If we can't put one triangle on top of the other exactly, then they're not similar. And we'll see that because we can't match up the angles, and we also can't create the ratios because all the ratios would be different. So let's go ahead and click on tools because it's a little easier to explain all this with the actual tools. Okay, so these are the tools that I was talking about. So what we want to do is we want to take this one. This is the translate tool. So once I have this on, I can click it and I can move this triangle. So if you notice, none of the letters are moving with it like it did on the last screen. So we just need to remember right now we have T on the top, R on the left, S on the bottom. So I've moved it over here, but it looks like I need to rotate it. So now T is actually on the right side there, but that looks the wrong orientation. So I'm going to flip it and then rotate it again. So this looks pretty close. So I'm actually going to bring it really quick over here. So remember, all I did was rotate it down like this. So this is just directly upside down from this one, or pretty close to it anyway. So this S is going to match with this D. So we might want to go ahead and select that now. S and D. R is going to match with E, and T is going to match with F. So it might be a little easier to do that before you kind of snap it into place there. So let's spin that back around. And then we're going to grab this tool, which is to make it bigger or smaller. So we just make it a little bigger. And then we need to translate it a little bit more here too. Uh-oh, I don't know if we can actually do this one. It doesn't look like we can actually do this one because we have a matching, but it's a little too big. So we might have to select we can't. This is not possible. Yeah, it doesn't look possible to me. Let's see. Oh, maybe that might have been it. Oh, that was it right there. So it was just my bad. I kept making it the wrong size there. Okay, so you just keep messing with that until it finally snaps into place. Not possible is an option. So if they are completely different size triangles, you can click not possible. Not different size, sorry, different shaped triangles. Because they're going to be different sizes. It's the shape that we're worried about. All right, so we're going to go through and match it up. So we have ED, which is 27, to RS, which is 18, and then DF is 15, ST is 10, and I'm just taking this right off the diagram. So if it says ST, I'm going here's S, here's T, and that's 10. EF, 24, and RT, 15. So really quick, I typed these in and I did not reduce them. So now I need to go back and I need to reduce them to make sure I get I want the same ratios here. So it looks like 27 and 18 can both divide by 3. So if I divide by 3 on the top, I get 9. If I divide by 3 on the bottom of it, I get 6. Okay, I could have divided by 9, right? So it's okay if you don't see that right away. That's why I went ahead and divided by 3, because I can go 9 divided by 3 and I get 3. 6 divided by 3 and I get 2. Okay, so it looks like I can divide by 5 here. I'll get 3 on the top, and if I divide by 5 on the bottom, I get 2. This one, it looks like I can divide by 8. Again, if you don't see 8 right off the bat, you can do 2, and then 2 again, 2 again, or maybe you saw 4 first. It's totally up to you. I know they both divide by 8, so I'm going to do 3, and then the bottom turns into 2 when I divide by 8. So they all end up the same, so I get to click that they are all similar. And I knew they were similar because it snapped into place. This shows me that they are in fact similar because I can take this triangle, make it a little bigger, and it's the same as this one. Next. Okay. So we're going to take this triangle here, and we are going to spin it around. Okay, so I'm taking G, and I'm spinning G all the way around here. It also looks like I want to flip it now. So G is actually, okay, so I'm going to kind of keep it this way. And the reason I'm doing that is because now I have G, H, I, and I know G is going to go to Y, Z is going to go to H, and I is going to go, oh no, I'm sorry, I is going to go to Z. I said that wrong. H is going to go to X. I was picturing that wrong. So I'm going to spin it just a little more here. And then I'm going to move it back over here. And I want to make it a little bigger. About that big, I think. And I need to spin it a little bit more and translate it over. All right, so now they snapped in place. I already know they're similar. It's snapped on top, so I'm going to click similar. And now all I have to do is my ratios here. So I'll type them in first, and then we'll go back and simplify. So YX is 49, GH is 28, XZ is 21, HI is 12, and YZ is 42, GI is 24. Okay, so let's go back and reduce. So 49 and 28 both divide by 7. 49 divided by 7 is 7. 28 divided by 7 is 4. 21 and 12, they both divide by 3. So 21 divided by 3 is 7. 12 divided by 3 is 4. And let's see, these both divide by 6. So 42 divided by 6 is 7. And 24 divided by 6 is 4. All right. Yay. One more of these. Okay. So let's take this one. Let's see. It does look like we want to flip it. So now this is P over here. Okay, so it looks like, before I make it smaller, so it looks like we have P, R, Q. So P goes to B, R goes to C, Q goes to A. R goes to C, Q, I believe that's good. All right, so now we just need to shrink it down here. Perfect. Okay, so now we're going to go through and fill these out. So BA is 24, PQ is 32, AC is 12, QR is 16, BC is 21, PR is 28. Okay, so I just need to reduce these. Also, because I was able to snap this one right on top of the other one, I know it's similar already. So I know all of these fractions will have to reduce to the same thing. So it looks like I can divide by 8. 24 divided by 8 is 3. 32 divided by 8 is 4. 12 and 16 can both divide by 4. So I end up with 3 over 4 when I divide by 4 there. And then both of these can divide by 7. So when I divide by 7, I get 3 and 4. Perfect, which is exactly what I wanted. All right, we finished that one. Yay.